I have here a set of KC daylights, and today I'm going to install this on a period appropriate mini truck. These are a classy accessory for any pickup truck from the 1980s. Most famously, these appear behind the cab of a particular 1980s Toyota and a specific 1980s cult classic. While a Toyota pickup this isn't, a very 80s machine this is. By the time this video comes out, my buddy will have taken this piece of 80s goodness on the Southern Fried Heaps Lemons rally that'll go from Mobile, Alabama to Cedar Key, Florida. He's put in a ton of work, and we filmed everything he's done for a challenge that he and another friend of mine have started. Check out Millennial Wrench. They'll be popped up in the corner, and I'll have a link in the description. Enough talk. Let's get to installing some accessories on this baby. I'll have some help from the aforementioned buddy. Each of the lights individually draw 100 watts of power. Directly connecting these through a single switch is, needless to say, a bad idea. The total current draw is about 8 amps each, rounded up to 10 amps to give me some headroom in circuit design. The switch we'll be using say they can only handle 6 amps, and even that spec I'm pretty suspicious about. For safety, we need to activate these lights in a way that doesn't send 40 amps through the switches on a potentially cramped dash. Relays are a common part that are used in vehicles to turn on accessories and critical components that draw a lot of current. Fans, lights, heaters, and other things can draw high currents that would quickly heat up and melt a switch or fry a semiconductor. The basics of a relay is that they can switch a high current circuit, usually 15 to 30 amps, with a low current circuit, on the order of a few hundred milliamps. Common automotive relays are fairly standard, and often are ISO Type Bs, where the terminals for the two circuits are directly across the relay. This makes visualizing what is happening easier. The terminals are numbered 85 and 86 for the switching circuit, 30 and 87 for the output circuit. A lot of these relays will also have an additional pin labeled 87A. The printouts are printed somewhere on the relay with a very basic diagram. Now, you may have a question. Why are these numbers used? One simple answer: standardization. Remember, I said these are a standard style of relay. Nearly any vehicle using the size of relay will almost always have the same pinout, and the numbering is defined by DIN 72552, which defines standard numbering for all automotive wiring. The DIN standards related to this relay are as follows: 30 for from battery positive direct, 85 for relay coil negative, 86 for relay coil positive, 87A for normally closed contact, and 87B for normally open contact. Do note that the DIN standard also states that 87 is common contact, but often relays simply label 87B as 87. So much for standards. The relays I have support a maximum of 30 amps of current. Still, I'll be using one relay for each light. My reasoning will be evident in a moment. Each relay's pin 30 can be tied together and connected to the positive terminal of the battery. For safety, we'll add a 40 amp fuse and use 8 gauge wire. From pin 87 on the relays, we'll use a 10 amp fuse and some 16 gauge wire and run out to each of the lights. For controlling the relays, the circuit will have less stringent requirements. Because of the low current requirements, the gauge of wire won't be as critical, so we'll use a thinner gauge wire or whatever I have on hand. Something that can handle up to half an amp. Still, we'll want to add fuses for safety, something no greater than 5 amp. From the fuses, a wire will run to the switches. One for the inboard pair and one for the outboard pair, and from the switches to pin 86 of each pair of relays. Pin 85 of all the relays can be tied together and sent to a ground on the chassis. And there we go, the circuit we need to create. I have a bunch of these relay couplers, and it makes building relay modules like this significantly easier. They are easily tied together and make swapping out relays a breeze when that inevitability needs to be done. I don't like or trust the wires these come with, so I remove them from the couplers I'm using. I have the connectors I need to put my own wires in their place. I don't think there's really a debate regarding crimping versus soldering in automotive wiring, but here's my thought on the matter. In a harsh vibrating environment, I'd rather rely on a mechanical connection rather than a soldered one. As you've seen in a past video, solder joints will crack over time. Plus, soldering inside a vehicle can be a pain and runs the risk of melting or burning things that you don't want to melt or burn. And like that, the basic relay module has been created. I've left a few of these connections open because until I have the wire run, the ends of the wire aren't properly to length yet. Until I route them through the truck, I won't know exactly what length I'll need. The ends of the wire will be trimmed to length, and I'll throw a connector on the end of them so that components can be swapped out in the future. Let's go to the truck. I like to follow existing harnesses when I route wiring. My opinion is that if someone, at first glance, can't really tell you did anything, you did the wiring job right. I cannot tell you how many times I've come across wiring that was added to vehicles that were painfully obvious and absolutely atrocious. We won't achieve that level of perfection, but it'll look good regardless. I already installed the fuse block in place, and to support the higher load, my buddy fabricated a bracket and installed an upgraded alternator. We ran a new main wire from the alternator to the battery and tied it into the vehicle's existing wiring harness. Additionally, while I routed these wires in the cabin, my buddy went ahead and installed the lights on the truck. We poked the wires through an existing hole in the floor of the cabin. Now that the wires are in place, I'll trim the wires and add connectors to the ends. As you can see, there's more switches than the 2 specified earlier. There are plans for a key switch bypass that isn't in the scope of the video, and I wanted to make sure that it's been provisioned for. I already wired up this panel with the switches we intend on using. There's a connector inside of the dashboard where the harness will plug into. As a note, these connectors are some of my favorite for automotive use and are a step above the simple spade connector. They're dust and moisture resistant and are great for creating connections that won't corrode or accidentally short. Plus, they look way cleaner than a bunch of spade connectors. These lights just round out the look of the truck. 80s as hell, these are a fantastic classic accessory to top the roll bar. It may not be a Toyota, but my buddy can feel like Marty McFly rolling around town in this thing. But I'm stalling. The moment of truth. Let there be light. The lights complete this truck, and I'm pleased with how the harness came out. Hopefully the principles of relays, how they work, and how to incorporate them into your own projects was helpful. Too many people throw things into their vehicles without knowing how to do it safely, or unquestionably install kits and not really understanding what those little warts in the harness do beyond clicking and making stuff work. If you're interested in knowing a little more about this truck and what's been done for it, check out Millennial Wrench. They're just starting out and have a few things brewing in the pipeline. This truck is one of the many projects they plan on doing. A link to their channel, once again, will be in the description. Links to my Twitter, where I yell into the void about my channel, and Discord are also in the description. And as always, thank you for watching.